Hello and welcome to this section in further mathematics. Today we'll be discussing on the topic dynamics, and our focus will be on Newton's laws of motion. Newton's laws of motion. Now, the laws of motions. The first law of motion states that a body will continue in its state of rest, or if in motion will continue moving in a straight line until an external force acts on it. Now, the second law states that the rate of change of momentum of a body is directly proportional to the applied force and takes effect in the direction of the force while the third law states that to every action there is equal and opposite reaction. Okay, now let's start in. These are the three laws that governs dynamics, and was propounded by Sir Isaac Newton. Now, the first law of motion, which is also known as the law of inertia, states that a body will continue in each state of rest, or if in motion, in uniform motion, will continue moving in a straight line until an external force acts on it. This is just trying to tell us to explain the effect on force on a moving body, and it's trying to also explain to us that force tends to cause a body to deviate from motion, or to start a body, to make a body to start moving if that body is at rest. I think this is a law that shows the relationship between force and motion of a body. Now, the rate of change of momentum of a body is directly proportional to the applied force and takes effect in the direction of the force. Now, this second law of motion, momentum is mass times velocity. So we now have F is equal to mv minus mu. That's mv is the final velocity, mu is the initial velocity, all over time. So at this point, we now have F to equal to m in bracket v minus u over t. So the value of our F and is equal to m times v minus u over t is acceleration, that's change in velocity. So from here we have F equal to ma, and this is relation with Newton's second law of motion. So this helps us to prove that force is equal to mass times acceleration. And the third one, it states that to every action there is equal and opposite reaction. Now, let me ask you a question. Have you ever wondered why, if you are swimming, let me say you are inside the water, you want to swim, and each time you push the water forward, you see your body going backward. Or when you try to push the water backward, you see yourself going forward. This is to tell you that the same amount of force you exert on the water is the same amount of force the water is sending back to you. That is why when you're inside trying to swim, you can't take the water forward and you see yourself moving forward. The water will try to resist your movement, and that is why you see yourself going back. So action and reaction are equal but opposite in direction. So that is what Newton wanted to prove with his third law of motion. Now with this, I want us to go into solving just a simple analysis that involves this. Let's call it example 1. Let's say a boy sits on a log. The mass of the log is 8 kilogram, and the weight of the boy is 55 Newton. What is the reaction of the ground? What's the reaction of the ground on the log on which the boy is sitting? Now, the first thing I want us to do at this point is to get the weight of the log. Remember, weight, which is proportional to force, is equal to mass times acceleration. And the mass of the log is 8 kilogram times the acceleration was given to us. The acceleration was given to us to be 9.8 meters per second. So the weight of the log is equal to, we have 8 times 9.8, which is 78.4 Newton. And the weight of the boy is equal to 55 Newton. Now, in order for us to get the reaction of the ground towards the log, what we need to get is the reaction of the boy and the log towards the ground, since action and reaction is opposite but in a different direction. So with this, we add the weight of the boy and the weight of the log. So we have 55 plus 78.4, which is equal to 55, that's 1, 2, that's 3, plus 3, 1, that's, we have a total of 133.4 Newton. Now, this is the reaction of the boy and the log, summation of the boy's weight and the log to the ground. But according to Newton's third law, action and reaction are equal but opposite. So therefore, the weight of the ground to the boy should be also equal to 133.4 Newton. So I would like to say a very big thank you for you being part of today's lesson. Just do yourself a favor by attempting the question that will be popping up very soon on the screen. Always make sure you consult this platform for guidance on a certain issue that involves dynamics. We'll be looking forward to hearing from you. Thank you and see you in our next lesson.